Welcome to Exercise 10, Nutrient Analysis. As always, you should have already watched the lab lecture, read the lab introduction, and watched the lab introduction video, which will give some background to what we will be doing in this lab. Today, we will be looking at how different nutrients change with depth in the water column and between the surface of a river and the open ocean. First, we will look at phosphate, which is an essential nutrient for photosynthesis. As you can see from these bottles, we have samples taken from 10 different depths: 0, 50, 100, 200, 500, 1,000, 2,000, 3,000, 4,000, and 5,000 meters, as well as a single sample taken from the Elizabeth River at 0 meters that we will call natural surface sample. You will want to write these depths in your table, starting with 0 meters at the top and ending with 5,000 meters at the bottom. Next, we will use the kit that you see on screen to find out how much phosphate there is in the water. This works by reacting with the phosphate in the water and changing color based on how much phosphate there is. Here, we follow the instructions provided with the kit, which works like a recipe. Add 10 milliliters of the water sample, 1 milliliter of phosphate acid reagent, mix it, then add 0.1 grams of phosphate reducing agent, mix it again, wait 5 minutes, and voila! The water changes color and we are ready to get the phosphate concentration by placing the sample in this reader and comparing it to the color at the bottom. If you didn't follow these instructions, your color would not be correct. We started at 0 meters depth and have matched it up to the closest color at the bottom. All you have to do is read the number at the bottom and write it down in the appropriate column and row in your table. For this, the units are ppm, or parts per mil. Now we have to do this 10 more times for this nutrient, once for each depth. Lucky for you, we did all of the sample preparation, and you just have to take the readings, with the depth of each reading written on the bottle on the left. This last measurement is labeled natural sample. Make sure that you write it in part 10, which has a separate chart. Next, we will look at nitrogen in the form of nitrates, another essential nutrient for photosynthesis. The process is the same. We will add chemicals from this testing kit to each depth and wait for a color change. The readings are done the same as they were for phosphate, except for this one. Please multiply all of your readings by 4.4 to get it into ppm. It is just the way this testing kit works. You don't need to do it for any others, but please multiply all numbers you read on this one by 4.4. This last measurement is labeled natural sample. Make sure that you write it in part 10, which has a separate chart. Next, we will look at ammonia, another form of nitrogen. Once again, we will follow the instructions and add the chemicals to a water sample of each depth and wait a few minutes for the color to change. The readings for ammonia are done a little bit differently. Just compare the color of the tube on the left to the scale on the right, and write down the number whose corresponding color most closely matches. The units for this are once again in ppm, or parts per mil. This last measurement is labeled natural sample. Make sure that you write it in part 10, which has a separate chart. Finally, we will look at silica, which some phytoplankton and zooplankton use to make shells. Same as before, we are going to add chemicals from a testing kit to a water sample of each depth, shake it up, and wait a few minutes for the color to change. The readings of this one are the same as for nitrogen. Just find the closest color on the right and write down that number for your measurement. The units for this are once again in ppm. This last measurement is labeled natural sample. Make sure that you write it in part 10, which has a separate chart. That's it, you're done with measurements. Please answer all questions in the lab before moving on to the next video, where you will make an Excel graph. If you're having trouble answering any of the questions, think about what we measured here, nutrients. We looked at nutrients with depth and nutrients in an estuary versus the open ocean. Where are the nutrients more abundant and why? Are there more at the surface or deep in the water column, and why? Would there be more nutrients in an estuary like the Chesapeake Bay or in the open ocean? And finally, would there be more nutrients in the summer or in the winter? If you're not sure how to answer any of these questions, please revisit the lecture video as the answer to these questions are found within.